Welcome to KEB America, where we're excited to welcome you here today for this demo as a part of our remote PAC Expo. Today I'm here to talk to you about how to walk through an EtherNet IP drive startup. This will be utilizing our S6 and F6 drive platforms. These come standard, where they offer great performance and flexibility with a power range of up to 500 horsepower, so they can fit into most any application. They come standard. Many great features such as a 32-bit internal positioning module for single-axis motion control applications, SIL 3 certified safety functionality such as safe torque off and safe brake control, a dual multi-encoder interface to support all major encoder protocols, and a flexible Ethernet interface to support EtherCAT, PowerLink, Profinet, and most importantly for this demo, Ethernet IP. Also importantly, they come with our COMBIVIS 6 programming software that allows you to connect to the drive and do uploads and downloads, but also comes with many beneficial features such as the wizards, which we will display in this demo, and then also our scope function, which allows you to trace up to 16 parameters in real time. Before we get started, just want to give an overview of the hardware we're working with. So at the top level, we have an AllenBradley Compact Logix 5380 PLC that's communicating via Ethernet IP to our S6 drive, and then that in turn is running a KEB DL3 servo motor. So to connect to the drive, we'll need to use the KEB COMBIVIS 6 software. So that's a free download off the KEB website. It includes everything needed to connect to the drive, perform uploads and downloads, and then has some other helpful features built in, such as the scope functionality, which allows you to trace up to 16 parameters in real time, so you can view how they're behaving throughout the operation, which is exceptionally helpful for startup and for troubleshooting. And there are also many wizards built in to make the start of a breeze, which you'll see shortly. So first, we'll just need to connect to the drive. So we'll do that using the KEB device scan. So you get this pop-up window. It'll automatically detect what ports are connected. You'll just need to start search, and then in a matter of seconds, it should detect the drive. And there it is there. Add selected devices, and we're off and running. So it'll start you off here. Typically, best practice is to do a default when you're starting up, just to make sure you're starting from the same place every time. But to save some time, I've already done that, so we'll skip that portion today. So the next portion is the motor wizard. This is where you enter your motor data and some other relevant motor parameters. So if you have a KEB part number, it's as simple as just typing in this part number up here, and you'll see it's automatically loaded down here. So it just automatically pulls in that data. If you're using a third-party motor, you'll just need to select your motor type and then add in your basic nameplate motor data. These should be readily available for any motor. It'll also give you a couple of other options. You can adjust if you have a temperature sensor or not. Here in the generator mode, whether you're using a braking resistor or not. And then also if you're using a brake with the motor, you can control whether opening and closing times and how you're controlling the brake. Next up is the feedback mode. So first off, for this, you'll need to select your control mode. So you have your open loop volts per hertz mode here, and then there are two closed loop options. The first is the standard encoder with our encoder-based closed loop. The second is our encoderless or SCL or sensorless closed loop. So that provides the same precise speed and torque control of your standard closed loop, but doesn't need that encoder feedback. There are also a couple other handy options here. You can do the system inversion. So if you're giving a forward direction command and expecting it to run clockwise, but it's running counterclockwise instead, rather than having to switch your wiring, you can just invert it here in the software. And it also gives you two options for your speed control and your position control. So an example of this would be if you have an encoder mounted on the motor shaft for speed, and then another encoder mounted on the output of a gearbox for your position, so you can use those two different sources. And then finally, just to set up the encoder, we don't have to do this in this case since we're using the KEB part number so that automatically was drawn in as well as the motor data. But if you're using a third-party motor, again, you can just enter that here. So next up is your controller. So this is where you adjust your speed and position controller. So first off is just the inertia. Your motor inertia should be readily published from the motor manufacturer. The load inertia can either be calculated or just adjusted during tuning. You can adjust torque limits within here, and then there's also our controller performance. So you can see up here we use a proportional and integral controller or a PI controller. You can adjust them independently, but they are dependent of each other. So what we've done is put this optimization factor down here so they moves them together. In this case, a lower number is a harder performance, which means it adapts more quickly to deviations in the actual and command speed. A higher number is a softer control. And then if you are using positioning, you can also adjust your position control loop, which in this case is just a proportional controller. And then next up is your protections and warnings. So the drive has quite a few protection functionalities built into the drive. These can be to protect the drive itself, but also to protect the motor or the machine as a whole. So a couple of examples for this. So like you can see the watchdog here. So the response if the Fieldbus communication is dropped off. Motor thermal overload, so to protect the motor from overheating. Protections for like if your encoder cable is disconnected, and many more. So just to save some time, I'll skip through some of these, but just know that there are quite a number of protection functionalities built into the drive. And again, they can be not only just for the drive, but for the motor and machine as a whole. So the next tab is the identification wizard. So this is the drive's motor identification. So this takes a measurement of the motor on values such as the stator resistance and inductance. And then that in turn is used within the drive's internal motor model to have more precise speed and torque control. One helpful feature of this is it can be done statically. So if your load is already connected to the motor, you don't have to disconnect it to do this identification. You can do it without movement. So this process only takes a minute or two, but again, just to save some time today, we'll skip through it and we'll go on to the modes of operation. So here's where you select what type of mode you're using, and then a couple of other application-specific values or adjustments within that mode. So if we select velocity mode, you can select whether it's an S-curve or a linear curve for XL and decel. If we select S-curve, you can select your max and min speeds for both forward and reverse. And then you can also adjust the ramp here, which I think this screen in particular is very useful within the wizards. So you can select your target speed and then adjust your low and high jerk and constant XL time. So if we adjust this here, you can immediately see it reflected up in the graph above. So you can see exactly how your ramp is changing. And then you can have 4 different independent XL and decel ramps, or you can have them all mirrored to your forward acceleration. So last up is the Fieldbus setup. So in this drop-down, you can select whether you're using EtherCAT, CAN Open, Profinet, PowerLink, or in this case, we're using the Ethernet IP. And then you'll just need to set up your process data objects. So you can either use these drop-downs over here to create your own custom process data mapping, or in this stored mappings down here, you can load the KEB standard mappings. And then quickly, before we switch over to Ethernet IP control, just to highlight the test run wizard. So this is a helpful feature just to spin the motor for the first time. So it gives you some basic diagnostic information such as your state machine and some, whether your STO is set or if there's any errors, and then some basic push buttons for start and stop, and then, adjustments for, in this case, or command position. So now the drive is all set up, so we'll switch over to the AllenBradley setup. So again, we're using a Compact Logix 5380 PLC. I've already imported the AOIs and UDTs that KEB has created to make the communication and control setup a breeze. And then so for this control today, it's a relatively basic setup. So what we're doing is we're given a target position to the drive. The drive is then using its ramp profile to ramp to that target position. It is then sending a target reached status back to the PLC. Once the PLC sees that, it is dwelling for a program or a programmable amount of time, and then resending a new target position. So ultimately what we're doing is we're running it for a programmable number of revolutions, pausing, and then just repeating that over and over. And then it's as simple as just putting in a 1 here. And we're running. Camera here. You can see it's spinning behind me. So that wraps up the startup of the EtherNet IP drive. I hope this demo was a helpful introduction to the KEB product line and how quickly and easily the startup can be done for EtherNet IP utilizing our drives and the wizards built into our COMBIVIS 6 programming software. So if you'd like more information, please check us out at KEB America, or if you wanted to get a sample demo like this one behind me, or a sample unit of a drive like the S6, please reach out to us.